So I have a great honor of introducing a fellow Dominican, very exciting, Mr. Marty Hewlett. So Marty is a professor emeritus from the University of Arizona, Department of Molecular and Cellular Biology. He's taught at UNM Taos since 2003. He serves as a research scholar at UNM Taos and is an adjunct faculty member in the Religious Studies program at UNM. So Marty earned his Bachelor of Arts degree in chemistry from USC and a Ph.D. in biochemistry from the University of Arizona. He was a postdoctoral fellow at MIT, where he specialized in molecular virology. He has many awards and fellowships in teaching. In particular, people think he's a fabulous teacher, many teaching awards, and I always love that because I was once a student and I sought out those teachers. So let's see. He's been the principal investigator of numerous federal research grants from NIH and NSF. He's a recipient of an American Cancer Society Faculty Research Award, the Fogarty Senior International Fellowship. His research specialties include molecular virology as well as philosophy of science. And he is co-author of a couple of important books, Evolution from Creation to New Creation, and Theological and Scientific Commentary on Darwin's Original Species. And so please help me welcome Marty Hewlett.
Thank you so much for that introduction, and thanks to Chris and the board and the chapter for organizing this wonderful conference. Thank all of you for being here today to join in this fellowship. I'm going to start first by talking a little bit about Charles Darwin and the scientific work that he did that led to the book Origin of Species and the reception it had and the consequences downstream from it for biology. And then in the second part, I'll segue to what I call here the controversy. What happened that precipitated this blatantly scientific work into the social controversy that it has become almost since the day of its publication. So Darwin began his academic career heading off to be a doctor. He had gone to Edinburgh to study medicine. But he said that the lectures bored him and he didn't like the anatomy lessons. So he couldn't stand being a doctor. And his father dragged him back to Cambridge and forced him into a program of study that was to lead to him becoming an Anglican cleric. But during his time at Cambridge, he got interested in natural science. In particular, he met a man who became his tutor, an Anglican priest, John Henslow, who was a botanist, who introduced him to the wonders of the biological natural world. And after his graduation, Henslow is the one who recommended that Darwin take a post as the naturalist on the next voyage of HMS Beagle. The Beagle was a British ship that was a survey vessel to go around the world, basically showing the British flag, but doing important work also as it made its way around the world. And Darwin was to be the ship's naturalist on its second voyage. The voyage lasted some 5 years, from 1831 to 1836, and it was during that voyage that Darwin encountered the data, made his observations, and collected materials that eventually led to the conclusions he drew in Origin of Species. He returned to England in 1836 and basically never left Kent except for trips to London to visit with colleagues, but never left England again for the rest of his life. And it took him some 20 years before Origin of Species actually was published. And during that time, while he was at Down House in Kent, he was working on his theories. Now, the background of his work, the context with which he developed the theories that we see, the theory that we see expressed in Origin, are reliant on these figures in his life. First of all, there was William Paley, the Anglican cleric who wrote Natural Theology towards the end of the 18th century. That book had been required reading for him at Cambridge. In fact, he would often brag that he had memorized the entire text. Stephen Jay Gould argues that Origin of Species is written in such a way that you could say it is an exact structural argument against Paley's arguments in natural theology. And Paley's book is the one in which we find the example of discovering a watch on the moor and arguing that it couldn't have been placed there by chance, that it had to have been designed by an intelligence. I'll come back to that when we talk a little bit about intelligent design. The second influence, of course, is his own grandfather, Erasmus Darwin, who wrote Zoonomia, or the Laws of Organic Life. And it was in that book that Erasmus, his grandfather, began thinking about descent from some kind of common ancestral form. He didn't have a whole fleshed out theory, but he proposed that that would actually be a possibility for life. Okay? The third influence was Charles Lyell, the great geologist of the Victorian age, whose 2-volume book, Principles of Geology, Darwin took with him on the voyage. And it's in Lyell's book that we first start to find the arguments for deep time in terms of the age of the Earth. Next comes Jean-Baptiste Lamarck, who had already published his own theory of evolution. And in Darwin's work, in Origin of Species, he does a point-by-point refutation of Lamarck's ideas for inheritance of acquired traits. So that's another big influence. And then the final piece that he needed was the book written, or the essay written by Malthus called Principles of Population, in which he argued that populations increase geometrically, whereas resources only increase arithmetically. Okay, so that populations eventually outstrip their resources. So this was a key feature in his theory, the idea that populations grow with limited resources. Okay? So working at Downhouse, he eventually comes up with this, what I call a bold hypothesis for his time. So his theory of evolution argues that all living things that we see on the planet today descended from a common ancestor, and that the force that led to the adaptation and origin of speciation was natural selection. He used this term purposefully, describing it by comparison to what we call artificial selection. He said, just as agriculturalists select animals and plants for certain traits to have increased production, say of milk or corn or whatever, so nature does the same thing by imposing this selective force on populations as they expand in the presence of limited resources. He talked about variations in populations, modifications that arise. He did not know how they would arise. That's a key feature that comes later into the theory. But he talked about their adaptation to environmental conditions, and that breeding with limited resources becomes a key feature of it, and that these changes occur over deep time. He even argued for extinctions. On this figure you see on the top, a figure that Darwin had drawn in his notes during his work at Downhouse, and below is a sort of timeline, if you will, with extinctions. This is the only figure that's in Origin of Species, this particular one. And you can see that there are timelines that die out. So he even argued for extinctions here. The species issue here was defined morphologically, which again became a problem for him in arguing about what really is a species, because he was doing it morphologically. We'll see how in the 20th century that changes. There were 6 editions of Origin, the first being published in November of 1859. All 6 editions were edited by Darwin. So, what was the scientific reception at the time of this great work? Well, certainly most sciences accepted at this point that evolution, or some kind of descent with modification, did occur. However, the mechanism that Darwin presented was not convincing to many. he argued that natural selection is a force. And of course, in the 19th century, physics was the queen of the sciences, and force meant something to physicists, so they argued, on what does this force act? And Darwin had no answer for that in the 19th century. Another feature was that Darwin had no clear idea of how inheritance takes place. The prevailing notion of how inheritance takes place was blending inheritance. That is, that the characters of two parents were somehow blended in the offspring. Now, Mendel publishes his paper in 1868. No one read it, or no one paid attention to it. And it wasn't because Mendel was off in some backwater. He was actually in a research institute. That's what his monastery in Brünn was. But it was because that microscopy hadn't developed well enough to understand the nature of chromosomal movement in cells. That didn't come around until the beginning of the 20th century, when Mendel's work was rediscovered, which is why we call it Mendelian genetics, even though it was 60 years later that we actually understood what his quantitative laws of inheritance were about. But because at the time of Darwin's work, blending inheritance was the key, people like Fleming Jenkin, who was an engineer in London, wrote a piece in the London Times saying, this could never work because any positive selection for adaptation would be bred out in subsequent generations by blending. So in order to counter that argument, in the third edition of his work, Darwin actually had to fall back on his nemesis, Lamarck, and argue for the inheritance of acquired characteristics as the only solution to his problem. Had he known of Mendel, he would have been saved already. So it received a rocky start in the scientific world. We'll come back to the social issues in the second part. Now, eventually, in the 20th century, Mendel had been rediscovered. The laws of genetics were firmly established for all forms of life, especially at the work of fruit flies in the Morgan lab at Columbia. And so Darwinian evolutionary theory could be wedded with Mendelian genetics, and more importantly, population genetics, which was growing at the same time, into what Julian Huxley called the modern synthesis. Julian Huxley was the grandson of Thomas Huxley, who we'll talk about more in the second part. And so the idea was that small genetic changes, which we now knew of as mutations, within a population, gradually accumulate and become the substrate for natural selection. So the thing upon which that force acts would be the genes and their variations due to mutation. So the modern synthesis, which we now call the Neo-Darwinian synthesis, has become the overarching paradigm for biology since the publication of Huxley's work in 1942. And it still remains so to this day. So the kinds of evidence that have accumulated in support of this theory, and again, it's called a theory, which often lends its critics to the mistaken idea that somehow it's not supported, it's just, quote, theoretical. We call it a theory rather than a law because there's only one example of it, unlike gravitation, unlike genetics, where we call it the laws of genetics because virtually every reproducing kind on this earth obeys those laws of Mendel. But this is a one-off. So right now it's the theory of evolution until we see it at work on some other planet, and we can then maybe call it a law, that it obeys a law. So it is theoretical in that sense. But the kinds of evidence that we accumulate that support this are things like the paleontological record, which Darwin had pieces of as he made his trip around the world, collecting specimens of fossils, but which now we know in much greater detail. And in fact, critics of evolution will argue, well, you're missing pieces. For instance, whales are mammals that were originally land animals that migrated back to the sea. And so for a long time, critics of evolution said there are no fossil forms that represent that, so that can't be. But the fossil forms have now been found in the paleontological record. So that's still a rich source of evidence for the model. Another source are cladistics and phylogenies. So phylogenetics are trees, like I've shown here on the lower left, relating various organisms, metazoans in this side where we are, fungi and plants in this particular one, back to what are called last common ancestors, those points in the graph. So we can see by relating them, and for a variety of ways that include now molecular data, that we are related by these phylogenetic trees to a common ancestral species. And finally, there, of course, are all the molecular data that have been accumulated, such as the evolutionary changes we see over time for various proteins in terms of amino acid sequences, like cytochrome C is a very stable protein, that lower curve, whereas things like fibronectin, fibrinopeptides have diverged quite dramatically. But we can see this relatedness. And some of the greatest evidence are things like the very genetic code itself, which exists essentially the same in virtually all of life on the planet. So there's a lot of support for what we call the theory of evolution, especially the Neo-Darwinian synthesis of it. Now, that's not to say that it's under constant scientific assault by bringing up things that have been discovered. Stephen Jay Gould punctuated evolution, okay, where he argued for rapid changes over small amounts of time, was a great change in the theoretical framework, okay? Things like acquired large changes like the formation of eukaryotes, where one cell endosymbiotically engulfs another to make what was a prokaryotic kind of organism into a eukaryotic kind of organism. The origin of our mitochondria and chloroplasts, for instance. Sudden changes like that are in the record that have challenged a bit the theory of gradualism that people like Dawkins likes to champion. But still, the overarching paradigm is the Neo-Darwinian synthesis and has survived all this time since the publication of Origin. Now, the fallout from the Darwinian model in society was quite different from what happened in science. So, sure enough, Darwin's idea that all species on the planet descended from a common ancestor rather than the Genesis story of creation in kind, okay, which had been prominent up to that point in a lot of thinking, was a shaking point, a shock. But it wasn't that much of a shock theologically. Already in the 4th century, theologians had been arguing not to take Genesis literally. Augustine wrote even earlier than that you can't take Genesis literally and say that what you're reading counters the science of the day. For him, the science of the day was the Greek sciences, right? So already theologians knew that Genesis was a metaphor, if you will, of creation that was written for a particular purpose for the children of Israel during their Babylonian captivity. And all that was part of the backdrop. But even with that, this could have been a shock to the sensibilities of Victorian England and others. But that wasn't really what resulted in the controversy. Rather, it was what I call the overlays, the overarching, the additional layers that were placed on Darwin's work. For instance, Herbert Spencer, who was a great luminary in Victorian England, scientist and economic theorist. He's the one who came up with laissez-faire capitalism. It's to him we owe the idea of social Darwinism, taking Darwin's theory and applying it to society, saying, well, if nature selects for only those that are adapted, why don't we in society do that by letting the weak fall by the way? So he argued against social systems that Christians would normally support, to support the weak and infirm and the poor and all of that, but rather let them die by the wayside. Okay, he's the one that actually coined the phrase survival of the fittest that was in his 1864 book, Principles of Biology, that Darwin later incorporated into Origin in the 3rd edition, I believe. Now, by the way, survival of the fittest does not mean the nature red in tooth and claw kind of image that people have, that there's a competition between species and one kills the other within that and bang. No, it's reproductive survival. Do your genes survive to the next generation? Okay, that's really the issue. And so sometimes survival is actually avoiding predation because you've evolved an adaptation that gives you protective coloration. There was a great example of that in action in England in the north part of the country, in the industrial section, the early 20th century, when there were moths on trees that were predated by birds, and the moths had a light coloring that blended in with the bark, so those with the light coloring avoided predation. But when coal belching factories started producing soot that coated the trees, suddenly the dark-colored moths were the ones with the advantage to avoid predation by birds, and we saw a shift in the population dynamics from the light-colored moths to the dark-colored moths. So here, survival of the fittest were those who avoided predation because of an adaptation of pigment. The other big luminary was Francis Galton, who was Darwin's own cousin, who was a great polymath in Victorian England. He was an explorer. He's the one that developed fingerprints, actual physical fingerprints, as a forensic tool. But he's the one who coined the term eugenics. And he wrote a book called Hereditary Genius, in which he argued that if his cousin's work was correct, and nature could select for the most adapted, then we could select for the best among us, okay, by a couple of different methodologies. One is positive eugenics, in which you encourage the best to breed, and the other is negative eugenics, in which you prevent those you don't want to breed from breeding. Okay, and in his book, Hereditary Genius, he had a gradation of all human species, of who was on the top, and guess who was on the top? The British male. Actually, on the top above the British male was the Greeks, he thought were the ideal of human civilization. But just below that were British males. Okay. Now, eugenics had worldwide influence. Here in this country, people like Kellogg, Henry Ford, even Teddy Roosevelt were fans of eugenics. Oops.
The mic stopped working, so I'm just going to switch out real quick.
Cool. Thank you. Thanks, Liz. We're fans of eugenics. Oh, that is good. Yay! Should I start over? And so, yes, they championed eugenics. In fact, we had in this country fitter family fairs, contests at county fairs, and the fittest family would receive an award to encourage them to have more children, right? So this was true. But we also had examples of negative eugenics. We had the famous case in Virginia about the suppression of a family from reproducing. It went to the Supreme Court, the U.S. Supreme Court, to allow Virginia to sterilize a member of this family to prevent her from having children because they were defined as imbeciles, okay, with a lower IQ. And it was Oliver Wendell Holmes who wrote the assenting decision where he said 3 generations of imbeciles is enough. So that's negative eugenics. And that came to its ultimate horrible fruition in Nazi Germany. This book was one of the ones that Hitler read while he was in prison. And of course, we know what came from that, okay, were the pogroms against all the people in Germany that Hitler and his gang didn't like, including Jews and gypsies and homosexuals and everybody that didn't belong in the German state wound up in prison and unfortunately in gas chambers. And so that's when eugenics took its downturn in this country. That's when it got a negative press, let's say. And so the laboratory of eugenics, which was Cold Spring Harbor Laboratory out on Long Island, suddenly no longer existed, and now we have Cold Spring Harbor Laboratory of Quantitative Biology, a much better name and a much better use of the facility. Okay, so those were 2. But perhaps the most insidious was Thomas Huxley in terms of the impact of his ideas about Darwin on society. Because Thomas Huxley was the great scientist and philosopher of the age. He actually got a preprint of Darwin's book, and on the next day after it was, or the day before it was published publicly, Huxley wrote to him and said, "My dear Darwin, I finished your book yesterday." And in that letter, he writes to him about how what he has said in his book gives him all of the ammunition that he needs to fight against the Church of England. That he sees a new religion coming out of this book. He actually coins the word agnostic to describe himself, but that's not because he was an agnostic. It was because saying he was an atheist in polite Victorian society was considered rude. So he used the word agnostic to sort of bury over, if you will, his atheism. So here you had these three great things. You had social Darwinism, you had eugenics, and you had atheism, all flying in the face of the Christian communities, especially in England, and ultimately in this country. So the reaction was, naturally, if that's what Darwinian evolution means, why would we be for it? Why wouldn't we think that there was something wrong with this theory? Now remember, this isn't science at this point. This is social and philosophical and theological overlay on the science. The science of Darwin is simple. Here's the data, here are my conclusions, and here's a theory, and go ahead and test it. Right? Darwin held out to his dying day that his theory did not imply these social and theological changes, even though he himself wasn't a very religious person. But he says in his fifth and sixth edition, I didn't mean this to be a theological attack. And he actually gets some theologians to comment on that, and he quotes them in the book. Nonetheless, the idea that this was somehow antithetical to Christianity had taken root. So in our country, we wound up with what was called scientific creationism. And the origins of scientific creationism are often tied to fundamentalism. And I just want to say a word about what fundamentalism actually is. It stems from the Presbyterian Church of America's reaction to liberalism in the church in general, especially biblical criticism. And so they met and came up with what they called the 5 Fundamentals, which were published as a series of pamphlets. And so their idea was that to be a Presbyterian, you had to accept or believe in the 5 fundamentals of the religion, and that was why they were called fundamentalists. Okay? Now, they were not anti-evolution. In fact, B.B. Warfield here was an evolutionist. He very much believed in accepted Darwin's theories, used them in his homilies, in fact, as part of it. So this wasn't in itself an anti-evolution movement. It was an anti-liberalism and Christianity movement. But in America, it became related to scientific creationism as a derivative. Not directly, but a derivative. A derivative nonetheless in some circles. And so the idea that you could have creation science, for instance, which became an institute that was housed, is still housed in the San Diego area, where they were using scientific principles to study how evolution would work, became a real thing. And of course, scientific creationism was challenged in the Supreme Court in 1968, where the Supreme Court importantly said this is not science but a belief system because it's not subject to falsification. Steve Barr has already mentioned intelligent design, which then came up in the late 1990s as the next challenge to teaching evolution in schools. Reverend William Paley, who I mentioned in his Natural Theology, is sort of the origin of this idea of design. And as Steve very nicely said, it's a new interpretation of that word. The original was argument from order, or as Thomas Aquinas said, the argument from governance is what he used. So this makes the idea of this irreducible complexity in features of nature to be an important part of their theory. So the idea was at some point in evolution, evolution is taking place normally, a design intervention has to take place to get an eye, a human eye, to get other aspects of these very complex biological structures because they are irreducibly complex. Michael Behe, a biochemist from Lehigh, wrote Darwin's Black Box, and Bill Dembski, who's a mathematician at Baylor, wrote No Free Lunch, and those are the two foundational texts of the movement. Now, we're going to argue that this is not science also, and I'm going to argue for theistic science. So in the last couple of minutes, if I may, I'll take time to introduce you to theistic science. Steve mentioned the conflict model last night, the idea that science and theology are at war. This is one of four models that Ian Barbour and Jack Hewlett put forward, both theologians. Independence was the second one, represented by Stephen Jay Gould and his non-overlapping magisteria. Dialogue and integration, or conversation and confirmation, are the two that are involved in what we call the theistic response to evolution. So a little bit about Thomistic theism, which this is based on. So for Thomas, the existence of God is knowable in itself, but not knowable to us by reason. In other words, he says in the first line of the Summa, all you can know about God is that God is. Okay? Everything else you think you know about God is knowable by faith and revelation, right? But we have reason, and so using our reason, Thomas said, we can work a posteriori from the effects of God and use analogous knowledge. So God's action is analogous in a lot of Thomas's writing. The 5 ways are all analogies. Okay? So there's 2 ways that God works, creation from nothing and continuing creation, Thomas said. Now, Steve very nicely introduced us last night to primary and secondary causation. Primary cause is that properly ascribed to God, but as Steve mentioned today, God is not a cause in the world. In fact, it's almost wrong to use the word cause for primary cause, because Thomas used that as an analogy. He said, God is like or analogous to a primary cause, a cause without a cause. And everything else that we see in the world is secondary causation. And that's what we as scientists deal with, is secondary causation. So this is key to understanding intelligent design, because ID is a model that is explanatory, but does not have predictive value. You can't say that, well, the human eye was designed, and you can't do experiments to show that, by an intelligent designer stepping in. But more importantly, ID confuses primary and secondary causes. Bill Dembski calls the difference natural causes and what he calls intelligent causes. But Bill wants the intelligent causes to be a cause in the world, which God can't be. Okay, so that's a confusion that more or less invalidates intelligent design as an authentically scientific approach, because he inserts both non-prediction and non-falsification as well as a misuse of God's action. Okay, you can't make God a cause in the world. God is like a primary cause, but he's not an intelligent cause. So ID looks for purpose in nature, and science, by definition, does not do that, as Steve mentioned in the previous talk. So I argue for theistic evolution. It's not just me, it's myself, my co-author Ted Peters, and a large number of us. And these are the 4 premises we say for theistic evolution. The Neo-Darwinian model is accepted as a theory well supported by observations. And by that we mean the science of evolution, not the philosophical and theological overlays. Okay? Science observes secondary causes in nature, whereas God operates like a primary cause. And Thomistic understanding of causes validates that. Right? So we can't look at God as a cause in nature. Science cannot see purpose in nature. That's a self-defined role. But we believe, theistically, we believe as believers that God has a purpose for nature. And this is our theological reflection on evolution. Okay? Ted and I came up with what we call the divine action spectrum that plays across from interventionism on the left, which is creationism, that rejects ontological reductionism and all that, to actual atheism on the other side. We put theistic evolution in the broad middle between all of those particular sides of it. And here are some theistic evolutionists, myself and my co-author Ted are on the top, Bob Russell, founder of CTNS, Jack Howe, theologian at Georgetown, Ken Miller, cell biologist at Brown, and finally Pope St. John Paul II. And if I can quote from the letter that you mentioned, Steve, to George Coyne from 1988. I have it here.
Chris Liebman quoted it.
We got it from your website.
Oh, yes, we got it from your website. The two of you mentioned George's letter to the Saint's letter to George. And I want to quote another line from it where he says to George, "Science can purify religion from error and superstition. Religion can purify science from idolatry and false absolutes. Each can draw the other into a wider world, a world in which both can flourish." Thank you.
Thank you very much. We'll take a couple of questions.
I would just comment that Jack Haugh stood right where you are about 2 years ago speaking to the Los Alamos Faith and Science Forum.
Jack is a dear friend. So glad to hear that he's here.
Chip?
Just an aside, I met Jack and had a lot of time to talk to him, and I have a great feeling for him because he has a human feeling for the human race. And the way I know this is he likes the Kingston Trio.
Very good.
One more question. Anybody?
Can we get the slides? Are you going to do the slides?
Sorry?
Can we get the slides?
I'm fine with that. If you
Post
can,
all the slides.
as a
The
PDF, if you
speakers,
like. Sure.
agreements, yes.
Sure.
After the. Some questions.
Chris.
Was there other questions? So in theistic evolution, is this a framework that applies only to evolution, or is it like more of a worldview of how God interacts with nature? And my secondary question would be: would this model allow for God to intervene once in a while in nature as a direct cause or secondary?
So the second part of your question deals with miracles, okay, and how that can be folded into this. And that's a whole separate talk on how miracles are not something that is approachable by science, because they are by and large, they're exceptions. We deal with things that obey rules as opposed to the exceptions. The first part, though, is yes, I think this is generally applicable. We used it here because of the specific ignoring of primary cause and its meaning by the intelligent design model. But we wanted to make a general statement that what we do as theistic scientists, not just evolutionists, is accept science qua science, without the philosophical pieces that Steve mentioned in the reaction to his paper, right? That we accept it as science, and that we understand that we examine secondary causation, the natural causes at work in nature, and that we don't look for purpose in our work, but we understand by faith that God has a purpose for nature. And that's true for any of our scientific work.
You didn't mention the latest synthesis in evolution, which now admits of Lamarckian type stuff.
Yeah.
Could you comment about the fact that it seems like beings like a beaver or humans can involve a way to change the expression of their genes?
Right. So there's both epigenetic changes, which are Lamarckian, as well as horizontal gene transfer, which we thought only happened in prokaryotics, but we know now happen in eukaryotes and even higher eukaryotes. Right? And with respect to the Lamarck piece, there's a wonderful paper about the water flea and its protective cap, which is inherited from generation to generation, very much in a Lamarckian fashion. And so people don't want to call it that in evolutionary biology because there's still a kind of a knee-jerk reaction against saying, oh no, but it's true. Those are the patterns of inheritance, and especially for epigenetic changes.
So let's thank our speaker.